Hello and welcome to Stat 441 at Virginia Commonwealth University. This is the second lecture for the online course. In this lecture, we will cover part 1 of chapter 2 from the textbook. This chapter deals with the descriptive statistics branch of statistics. In this chapter, we will learn how to present graphical and numerical methods to explore, summarize, and describe data. The question is, how can you organize and summarize the data to make it more comprehensible and meaningful? And there are various tools available. One of them is making graphs and charts that will convey a visual picture of the data. And the other tool is getting numerical measures that will describe certain features of the data. So the procedures that we will use both for graphs and numerical measures will depend on the type of data, whether the data is quantitative or qualitative. So let's first look at qualitative data. We will look at some graphical methods and numerical methods to describe qualitative data. For describing qualitative observations, the first thing that we need to do is define the categories or the classes in such a way that each observation falls in one and only one category. The data set will then be described by counting the number of observations in each of the category. This is called the frequency. And we could also calculate the proportion of observations that falls in each category. Okay. These are the terms that will be used. So a class is one of the categories in which we can classify the qualitative data. The class frequency is the number of observations that fall in each of that category. The class relative frequency is the proportion of the total number of observations that fall in that category. To calculate relative frequency, we can take the frequency and divide that by the total number of observations. Here's an example. Let's say if you look at this table, it's a summary frequency table for cause of energy related fatal accidents, and there are 3 columns here. The first column is the category or the cause of the accident. We have coal mine collapse, dam failure, and so on and so forth. The second column is the frequency or the number of accidents in each category. So 9 coal mine collapses, 40 gas explosions, 4 dam failures, out of a total of 62. The third column is to calculate the relative frequency, which is the frequency divided by the total number of observations. So for coal mine collapse, 9 out of 62 is 0.145. That is the relative frequency. So as you can see, the total of the relative frequencies is 1. Let's look at the graphical techniques to describe qualitative data. The first type of graph that we can use is the bar graph. It gives the frequency or the relative frequency corresponding to each category, and the height or length of the bar will be proportional to the category frequency. Okay, here's an example. This is the same data that we just saw. So as you can see, it gives a visual representation of the data that we had. We can clearly see that gas explosion causes the maximum number of accidents compared to the rest of the data. The other graph that can be used to describe qualitative data is pie charts. Pie chart is a circular graph in which each pie or each slice represents a category, and the central angle of this slice is proportional to the category's relative frequency. Here is the example. It's the same data set. As you can see, gas explosions cause 64.5% of the accidents. So that's the biggest slice. And then we have nuclear, which is 1.6%, which is the smallest slice. Okay. Next, let's look at graphical methods for describing quantitative data. So we know quantitative data is numerical data. So we want a technique to describe, summarize this data, and detect any patterns in the data. So there are three graphical methods that we will look at. The first one is dot plots, second is stem and leaf plots, and the third is histograms. Let's look at an example and use this example to build all the three graphs. This data is EPA mileage ratings for 100 cars. So these are 100 observations. As you can see, we can hardly draw any information just by looking at these numbers. We have to make it more meaningful, more useful, and making graphs gives us a better visual idea of what these numbers represent. The first graphical technique is dot plots. In a dot plot, the numerical value of each of the measurement in the data set is represented by a dot on a horizontal scale. And if the value repeats, we put another dot vertically above the previous one. So this is what a dot plot looks like for the EPA mileage data. So as you can see, we have a minimum at 30, a maximum at 45. A lot of observations are around the range of 36 and 37. And if you look at the shape of the graph, it is a symmetric shape with a bell-shaped curve with most of the observations in the middle. The next display is the stem and leaf display. In a stem and leaf display, the actual numbers are displayed on the graph. What we do is we divide our values into two parts. The first part is the stem and the second part is the leaf. We list all the stems in a column, and then the trailing part of the trailing digits are put in front of the leaves that it represents, in front of the stems that it represents. So let's look at what a stem and leaf plot looks like, and then we can see how to make a stem and leaf plot. So this is the stem and leaf plot for the EPA data. So these are the stems here, starting at 30 all the way through 44. So the minimum observation was 30.0. The maximum was 44.9. The first two digits are being used as the stem, and the trailing digit is used as the leaf. So this gives us the shape of the distribution. As you can see, again, it's a symmetric distribution. The shape is similar to the one that we saw with the dot plot. So if you compare the stem and leaf and dot plot, the differences here, we have actual numbers. In the dot plot, we were using dots to represent these numbers. Okay, this here gives the number of observations. So here in the middle, we have 21 observations, 49 observations below 37, and then we have 30 observations above 37. Let's look at the third type of graph. It's called histograms. Histograms are used to display the frequency or relative frequency of the measurements which fall in each of the class intervals. So let's again look at a graph to see what the class intervals are and how we use it to draw the graph. So this is the EPA data graph. If you look at this axis, the x-axis represents the class frequency. So from 30 to 31, 31 through 32, so on and so forth, all the way up to 45. So class intervals are intervals of equal width, and we count the number of observations that fall in that range. So let's look at a class frequency chart for the EPA data for which we made this histogram. This is the class frequency chart for the EPA data. So as you can see, the class intervals range from 30 through 31, 31 through 32, so on and so forth. They are of equal width, and then we count the number of observations that fall in each interval. So the first interval is 30 through 31. So all observations up to 31 go in this interval. Starting at 31 up to 32 go in this interval. So we count the frequencies here. There are total 100 observations. So these are all 100 observations. 43 through 44 has 0 observations. So that's what the frequency is. And then we calculate the relative frequency, which is basically the proportion out of the total observations. Once we have the frequency and the relative frequency calculated, on the x-axis or one of the axes, we display the class interval, and the bar represent the frequency or the relative frequency. Okay, these are the steps that can be followed to construct a histogram. The first step will be to calculate the range of the data. Range is simply the largest observation minus the smallest observation. So we calculate the range. Then the second step is to divide the range into classes of equal width. Classes are usually between 5 and 15. For smaller data sets, we will choose a smaller number. For larger data sets, we will use a larger number. Once we have decided how many classes, we will write down the classes and count the number of observations that fall in each of these classes. This will be called the class frequency. We can also calculate the relative class frequency by finding the proportion of observations in each class. So class relative frequency is equal to the class frequency divided by the total number of observations. The final step is making the actual histogram. It's essentially a bar graph with the categories being the classes. So we use the frequency histogram, where the height of the bar is determined by the class frequency. And then a relative frequency histogram, the heights of the bar is determined by the class relative frequency. Okay, so we will not be making these graphs by hand. We will use statistical software to generate histograms and stem and leaf plots and dot plots. For smaller data set, it might be possible to do it by hand, but once we have larger data set, it becomes harder to draw these by hand. What you will see is that for large data set, histogram is generally more useful. The stem and leaf plot and dot plot, as you can see, we use the actual numbers, and we displayed each number with a dot in the dot plot. So it works well for smaller data sets or graphs where you want to retain the actual numbers. Okay, so this is part 1 of chapter 2. Please watch the videos on how to use R to make these graphs using your data sets. Thank you, and we will continue with chapter 2 in the next video.